And so vectors have both magnitude, which is like a number, and direction. So if I were to give you the speed, I'd say like miles per hour, like 30 miles per hour. But velocity, which is a vector quantity, would be like 30 miles per hour north. So it has both magnitude, which is a number, and direction. A vector is symbolized by an arrow, so you'll be drawing lots of arrows, and make sure you bring your colored pencils to class, and your ruler to class, and your protractor to class. The length is going to indicate the magnitude. And the angle is going to be represented the direction of the vector. When two or more component vectors are added together, they're going to act as one of them. It's called a resultant. And so you might have a plane pointed west, and the wind's blowing north, so the result's going to be going northwest. The resultant vector can be broken down into horizontal and vertical components. So you just got to know these sort of vocabulary terms so you know what we're talking about as we go along. When adding vectors, you're going to do something, follow a process here. We're always going to add vectors head to tail. So when adding vectors, the head of the first component arrow is going to be added to the tail of the second component vector. The resultant's tail is drawn from the tail of the first to the head of the last. And I know it's hard to understand what this means right now, but we'll draw some out and you'll understand. So let's do number 3. It says a plane is flying 15 miles per hour east. Well, I'm just going to use an arrow because our arrows are what vectors are going to represent. So I'm going to start there at the 0. And since 1 centimeter is 10 miles an hour, I'm going to draw that arrow 5 centimeters long. Okay, so I'll do this vector 5 centimeters long, going to the right because it's going east. And it encounters a wind that's blowing east as well. Well, if you notice the notes up here, it says when adding vectors, the head of the first component is added to the tail of the second component. So I'm going to draw the next one, the next arrow here, with its tail connected to the head, but the wind's only blowing 20 miles an hour, so I'm only going to draw that 2 centimeters long. And with this green so you can see this. So therefore, those two vectors are added together, but now I need to draw a resultant to show how fast the plane's actually going to go. I'm going to draw that in black here. So show the mathematical addition of vectors and draw the components and resultants to measure the speed. Well, you simply take the rule up here that says the resultant's tail is drawn from the tail of the first one. So I'm going to start right here and draw it to the head of the last one, which is over here. So I simply take my arrow. I'm going to start from the very beginning and go all the way to the very, very end. Now, most of the time, you can just do ones like this in your head. If you notice, the resultant ends up being 7 centimeters. Well, 7 centimeters times 10 miles per hour per centimeter, that gives you 70 miles per hour. And since it's a vector, you must have a direction as well, and that means it's going east. On part 4, it's exactly the same thing again, but now we're going to draw, the wind is going the opposite direction. So I'm going to start off with my first vector. The plane's going to the east at 50 miles an hour, I guess. And then the wind vector is going backwards. So we have to draw this again. But since it's going backwards, it's not going to go this way. I think I drew it a little bit too long. There you go. And, so now when I draw my resultant, I'm going to start from the tail of the first to the head of the last. My resultant ends up being 3 centimeters long, and 3 centimeters is the same thing as 30 miles per hour on this scale. And since, once again, it's pointing to the east, I'm going to make that direction east. So vectors are pretty easy in one dimension here. If you flip your note page over, we're now going to do number 8. That should not be a 3, it should be an 8. And it just says draw the horizontal and vertical components of the resultant below. and your resultant looks something like this that was drawn on the sheet. Well, I just said that every resultant can be broken down into horizontal and vertical components. So that means that this line that you see on this paper goes a certain amount to the right. Okay? So that would be the horizontal component. Let's see if I can make this different color. Okay? So that's your horizontal component. And it also goes a certain amount upward. This would be the vertical component. So you're always going to be breaking things down into horizontal and vertical components when things are going diagonally. So that's all you do there. It's just draw a line to the horizontal axis and a line on the vertical axis. Let's do number 4 now. Got a boat traveling east at 20 miles per hour, and the river's flowing. I forgot to put this in. Let's make the river flow south at 20 miles an hour because it's always going downhill, and south is downhill. So we're going to have the boat going east at 20 miles an hour. We're going to take our ruler here and draw the boat going 20 to the east, correct? And now I'm going to have the river going south at 20, so I need to turn my ruler over here. So if my river's flowing south, I now have to move my ruler over like this. Okay? I'm going to draw a line now going straight south. Oops, that wasn't very good. So anyway, you got your river going south here. That's a little bit long. And so the resultant is going to now go from the tail of the first to the head of the last, something like this. Okay. And so that red line there is the resultant. And now when we measure this line, we end up getting roughly about 2.8 centimeters. 2.8 centimeters then is going to end up being 28 miles per hour. Now that I have that measured, I also have to give the direction since it is a vector. And I'm going to take my protractor, I'm going to come up here and I'm going to put the eye of the protractor where I started. Okay? But then I got to turn the protractor around here. Oops, sorry about that. Turn the protractor around. And so if you notice that that red line comes down here to about the 45 line. If I were to extend this out, you can see that it would be hitting 45 here. And so since the zero, my zero right up here started due east, this is east, and I went 45 degrees, this is 45 degrees here, toward the south, I'm going to say that this is 45 degrees south of east. That's going to be the tricky part, is getting used to doing that. Well, then it says afterwards, show this using trigonometry. Well, if you're trying to figure out the distance that it, or the speed that it went, it's much, much easier if you use trig, because we know that a squared plus b squared equals c squared. So that means that c, which is our resultant, equals the square root of a squared plus b squared. So I'm going to take a, which was my first vector over here of 2, plane was flying 2. The other vector is also 2, but we're going to square both of those. So the square root of 8 ends up giving you 2.8, once again, and that's going to be 28 miles per hour. You can also figure out the angle here. So let me get rid of all this protractor stuff so you can see that. To figure out the angle, we're going to use this angle right here. This would be my opposite side. This would be my adjacent side. And if you remember from trigonometry, tangent of the angle equals opposite over adjacent. So if you just want the angle, you're going to take the inverse tan of opposite over adjacent. And so I'm going to then put in both the numbers. Well, the opposite side was 2, and the adjacent side was 2, and the inverse tan of 1, it's 2 divided by 2 is 1, ends up being 45 degrees. And once again, since the first line I drew went east and the second line went south, I went south of east. So this is 45 degrees south of east. Now, since it's a 45-degree angle, it really doesn't make any difference how you write that. You could say east of south or south of east, but not all of our angles are going to be 45. Number 10 gets a little challenging here because we have to draw it. We're not going to use trigonometry yet, but we're just going to draw it out. And so I want you to start down in the lower left-hand part of your paper and put the protractor just like I have it and the ruler just like I have it. So the ruler is going to be going up at a 45-degree angle over the protractor because the plane is flying 200 miles an hour. Well, if it's flying 200 miles an hour, that means I'm going to need a 20-inch line, or not inch, but a 20-centimeter line. So I'm going to take my first vector and go from the 0 up here all the way up to 20. So that means that's right at a 45-degree angle. It then says there is a 15-mile-an-hour wind that blows 30 degrees south of west. This gets really tricky. So watch what I'm going to do here. I'm going to take my protractor and I'm going to move it up here, but I'm going to turn it over because, I'm going to turn it over like this because I need to draw a line south of west. So I'm going to take the protractor and place the 0 of the protractor right on the end of that first vector because you have to add them head to tail. And if you notice, west is over here, and I want to go 30 degrees south of west, so I'm going to go towards the south. Well, here's the 30-degree mark right here. I'm just going to put a little tick mark right there. Okay. And then I'm going to take my ruler. This is going to get really, really tricky here. I'm going to stay right there, and then I'm just going to get my ruler to move here. Whoops, wrong way. Let me get the move here right. Okay, so I'm turning my ruler over. I've got the 0 mark right there on the end of the arrow. And then I'm going to bring the ruler down so it's going to go right over that red little tick mark there at 30 degrees. Okay? So now what I have to do is I have to draw a vector beginning at the end of the first vector, and I have to draw it 15 miles per hour, so that would only be 1.5 centimeters. So I'm going to just go straight to there, which is a real little teeny little line there. Let me make it a different color so you can see it. All right. I've moved the protractor out of the way so you can see it a little bit better now. Now you have to draw the resultant. Well, the resultant is drawn from the tail of the first vector, which is down here, okay, to the head of the last vector, which is up here. Okay, so I'm just simply going to draw a nice little arrow straight from the tail of the first one all the way up to the head of the second one. And I need to figure out, well, how fast is that plane going to go? Well, the way we're going to do that is by measuring it with our ruler. So we're going to come down here and put our ruler right there at that line. Let me turn my ruler over here. And I'm going to flip my ruler over. So now I got my ruler flipped over. It looks like it's about 18.2 centimeters. So we're going to write that down because that's going to tell us how fast the plane's actually going. So the line's 18.2 centimeters, so it'll be going 182 miles per hour. But that's not what a vector is. You also have to give direction. So now I got to bring my protractor back down. So when I bring my protractor back down, let me flip it over here, like so. Bring it down here to where it's at the very beginning. I'm going to be a little bit off here because my lines didn't start off right. But let's see here. It's right there. That red line was supposed to be at 45. I don't know what the heck happened to that. So that's not even close. But anyway, it looks like the black line now is about at 47 degrees. Since the 0 of the protractor is facing east, and that black line went towards the north, I'm going to say that's 47 degrees north of east. Now it wants us to do it using trigonometry. You notice it also says trigonometry right here. Let's figure out how in the heck we can do that. You're going to need a lot of room on the paper, so if you want to put it on another piece of paper, that's fine, but you're going to need a lot of room to do the math for this. So I'm going to erase this right here. We're going to do the trigonometry for number 10 in the second video, so this one doesn't get too long. And so just view video number 2 for vectors to find the trigonometric way of doing number 10.